Hello and welcome to another video on my channel. In this video I am going to discuss more about operator overloading in Java and one of its use cases, which is basically developing a symbolic math engine or package. Here I'm just going to demonstrate univariate functions, the functions that have only one variable, and let's call the variable x. Okay. Alright, so let's assume that our variable is called x, and we want to define functions that use this variable x, and then we can write any kind of math operation between them. So the idea here is that we start with the superclass, and that's going to be abstract, and we call it function. So function is an abstract class that implements the operator overloading. For example, if I add the function 1 plus function 2, the result should be another function that has the value of function 1 plus function 2. Okay? Now, in order to give the behavior of a function to subclasses, this superclass function, which is abstract, should define the behaviors that we want. For example, getValue returns the value of the function at a particular point, x. And for example, if you want to calculate the derivative of this function with respect to its variable x at some point, you just have the function diff, and these are going to be abstract. Okay? And then there is one special function which is the constant function, and that constant function, the simple factory, the factory method value of, which assigns a primitive to an object, makes sense, right? If a function is not a constant function, having this assignment, basically assigning a primitive to a function, doesn't make any sense if it's not a constant function. So the abstract top level function class doesn't implement the value of, but when we define different types of functions as objects, the FC, function constant, this constant function implements the value of method. Okay? So the abstract function class implements operator overloading, and then we can create separate subclasses: a constant function, identity function x, a constant a function sine of x, cosine of x, and etc. Okay? Now remember, the operator overloading methods should return an abstract function, a function, not the subclasses, subtypes. Okay? And the tip here that I'll show you later in Eclipse, that what we want to do is use anonymous classes when we're doing implementing the operator overloading, and use the method overriding to override these particular methods, these abstract methods. Okay? And then finally, we want to also override the toString method to get for example, the value of the function when we print it to console. Okay, when we represent it as a string. All right, let's head to Eclipse and see how we are going to implement this. And in the Eclipse, I have already created a project, Java project, Symbolic Math Demo, and here I am going to create a function, and it's going to be abstract function. The superclass is object, and I don't want to have any main method. Okay, so let's create this function. Okay, and in this function we want to have abstract, or maybe just public abstract double get value double x. So any function should be able to return a value of the function at some particular point. Okay, and now what I want to do, I don't want this function to have any constructor, so I can define the private and no arg constructor, which is private, so this abstract function should not be instantiated. And then let's not do this. And then I want to do add the operator overloading capabilities. Okay, and instead of writing them, I just go to what we had before. for example here in this interface, and basically copy and paste all of these: addition, subtraction. Okay, and then I'm going to replace the return type t with my function. Multiply, reverse, divide, reverse, and negation. And all of these are valid operations for functions because they're just numbers, right? The return type is, let's say, a double. You can also implement complex functions that take complex number, and we will get to that in later videos. Okay? Alright, so the complaint here is that, so the compiler complains that you have to add bodies to these, basically, to these methods, right? And let's remove also this. So, so what I'm going to do here, going to add bodies. To addition, reverse addition, to functions, reverse addition to functions, subtraction, and then subtraction, reverse, subtraction from the function, reverse subtraction from a function, multiply to a double number, multiply to a reverse multiplication to a double number, and here, and then division, and then negation. Okay, division and then negation. Okay, all right, so we need to add bodies. So what do we want to return? So if I add a double value to a function, it should return function. Okay, so I create a function fadd, a new function. All right, and then this is an abstract method, so it complains that you have to add unimplemented method, which is the get value. Okay, now when I add a double v to a function, I have to add it to the value, right? Basically, I call my function, and in order to do that, I have to first make a copy. Let's call it this func, this. So this is my current function, and then I'm creating a new function that returns this dot get value at the point x and adds v, this double to it, and then I return fadd. Okay, let's just understand what I did here. So basically what we're doing here is each of these overriding methods for operators has to return a new function. Okay, and the new function object must be a function that when I add, for example, for this add method, it should be this function plus value v. Okay, and in order to do that, I create a new function, and this function is exactly the same as my original function, but its get value must be get value of the original function plus v. Okay, that's how we override this method. And then in order to do that, I have to if I write this, I cannot use this here, because if I write this, it refers to this fadd object, okay, which is not correct. So this func dot get value, that's why I created a copy of this object, the current function that I'm in, and then overrode the get value method. Remember, if you wrong way of doing it is just saying that this get value plus v, because here this refers, if you use this keyword here, this refers to fadd function. You're inside this object fadd. Okay, so you have to first make a copy of your current this current object function, and then basically get the value and override it. Okay, So for reverse addition, it doesn't make any difference, but in order to make it more clear, I just write v plus this function. Create a copy of your original this object, and then create a new object, f add, and then alright, so what happens when we have adding a function to another function? What happens then? So instead of having okay, so you still create a copy of this, and then in the f add you have your original plus your v dot get value. Okay, so we call this original function get value, and then the current object function get value, and add them together, and it returns a function. For add reverse to a function, exactly the same thing, v dot get value at x. Okay, all right, now subtract, again the same philosophy. We create a copy of your current function and f sub, and in the f sub, remember for subtract the order matters. So when we say subtract, it means this function minus value v. Okay, and again, if you just use the keyword this, it's not correct, because this, when you're inside this f sub function, this refers to f sub function. Okay, and for reverse subtraction, basically what happens here, we write v minus this. I'm going to delete this. Okay, for subtract from a function, let's copy this, and then we get this function minus v get value function. Okay, and again, you should not use the keyword this. And the reverse subtraction from a function, v dot get value at point x. Okay, multiplication, the same thing happens. So you copy of this function, current function f mult, and then you use the copy of your current object, this function dot get value times v. Okay, and multiplication reverse doesn't make any difference, but just for clarity, I just put the v on the left side, because reverse means the object comes second. And for the multiplying to a function, I get the copy of the original or the current object times with get value. Okay, and then for reverse multiplication, again, it doesn't matter, but for clarity, I put the v at the beginning. Okay, and finally for division, what I'm going to do is let's copy this and just v is a double. Okay, and then divide function, I just copy this, and then divide reverse. Basically you copy all of this, and I take v and divide it by this function. Okay, and then let's copy this, and for reverse we get the v dot get value, and then for negation we just have the get value, you just multiply it or minus 1 or return minus this dot value. F negate. Okay, this is negation. F divide. Okay, all right, everything looks good. Let's double check. So what we have here is let me just okay, so we have a abstract function. It's the public function with a constructor, and then it has a get value method, and it's an abstract method. Okay, and this get value method returns a double and takes the value of x. So basically what we're saying here is we are implementing f of x, so function f of x with and it's abstract. Okay, so abstract function, and but then operator overloading supported, and we have add reverse, add returns f add reverse. Okay, add to a function, add reverse to a function, subtract from a double value, subtract from a reverse subtraction from a double value, subtract from a function, reverse subtraction from a function, multiply to a double value, reverse multiplication to a double, multiply to a function, reverse multiplication to a function, division by a number v, reverse division. Okay, and division by a function, reverse division by a function, and then negation. Okay, so everything looks good, and this is our abstract method. And finally, basically when we have this, now we are going to go and create a let's say fc, constant function, and it's a superclasses function. Okay, or let's just not do this and then implement it, add it separately. So from object f constant. Okay, and here we just extend the function. Okay, and it complains because you are forced to implement the abstract method, which is get value. For a function, a constant function, we have a private double x val, and then we want this constant function to have a constructor. So public fc with a double value of x, and then this dot x val equals x. Okay, or maybe x. So we can create a constant function with this, and then when I get the value, I just return x val. All right, and then what I want to do also, I want to override the value of to be able to assign a primitive type double to this constant function, which makes sense, right? So let's write our documentation. This is a constant function. fc of x is just equal some constant c0, and assignment to primitive supported. Okay, basically fc equals 2.3 is supported, for example. And in order to support that, we override basically the value of, and it has to be a static. Remember, this simple factory of value of has to be static. Public is, and it has to be the return type should be fc. We can double check whether it should be fc or function. Public static fc, and value of double x, and then return new fc and apply x, or double v, maybe let's call it v, the double value. Okay, now in order to test this, for test I'm going to add a main method here, or maybe let's just create it another it's called another class, test func, and we want to have a main method. Alright, what do I want to do? Assignment of fc. So I can say fc f1, fc1, new fc 2.3. Okay, and let's go back here and also override the toString method. source override implement methods, and what we want is from the object, which is the superclass, to a string after. Okay, and instead of calling the superclass constructor, which is from the object class, we just say we can just say return the xval plus. Okay, or we can call the method getValue and then pass in the xval. But let's just do the xval and concatenate it with a string, empty string, to make it a string. Okay. All right, let's test this. System.out.println fc1. Let's see what happens. 2.3, and this is the ordinary way of creating a function, right? But then using operator overloading for assignment. So fc2 2.3. Let's see if it works. See, the compiler doesn't complain. And if we do a system.out.println fc2, let's call it 2.4, it should return the 2.4. Okay, so the value of is working. And if you want to make 100% sure that the value of method in the fc class is being called, let's go to the bytecode viewer and let's see what happens here. Here it just creates a new fc and push it to the stack, and 2.3 is pushed also, and invoke special is basically initializes the constructor. Okay, and then it prints the function. Here what happens here? Here it loads the 2.4, pushes it into the stack, but invokes a static method. What method? It's in the fc class dot value of, and the input parameter is double, and the return type is an fc object. So the value of method, that simple factor, is actually being called. Okay, so there is no doubt about it. What do I want next? Let's now let's make sure that check overloading for addition, for example. So we have two functions, fc1 and fc2. Let's see what happens. fc add, for example, fc1 plus fc2. Let's see if it works. Now it doesn't work. Why? Because remember, we wanted to have a generalized overloading for any type of function. So I cannot use a specific fc here unless I do a casting. So let's try fc on the summation, because here I'm promising the compiler that the return type, right now the return type of these two is going to be a function, abstract function, and I'm promising the compiler that it's indeed an fc function. So system.out.println fc add. Let's see if it works. No, it doesn't work. Cannot be cast to, so casting is not allowed here. So the other way of doing it, we just say this is a function. Okay, and then because we didn't maybe we should also go ahead and override the toString method for the function if we just want to have the basically print the value as the string representation. Okay, so toString method, I'm going to just call the getValue at no, it actually doesn't make sense to have the toString method here. So what I can do is just have the getValue at some, because right now it's a function, right? And a function by itself doesn't have any representation. A constant function, we can define a toString method based on its value. But let's check it at like 1. It should return, how much should it return? 4.7. Okay, so the overriding of the summation works, and it's indeed a constant function. So if I calculate at 100, at 10 for example, or 100, their value should remain the same. So this function is indeed a constant function. Okay, now let's implement the identity identity function, sorry, x. So this also extends a function, and we have to return the, basically override the get value, and it just returns the x. Okay, and then maybe it's better actually to, in the toString method, do something like f of x equals plus xval. If we want to override the toString method for each particular function, f of x equals just x, right? All right, now let's test the identity function. How do we do that? So test identity. Remember, identity function x, so we define a function fx equals x, and new x. Okay, and then let's create another function f x plus c, which is, we define f of x, or we can just maybe just call it x, capital X, or x, for example, x plus fc1. Maybe let's call it fx. Okay, now what happens, we have a x type function and then fc function, which was a constant. So basically this is equal to fx plus c is equal to x plus c, which was 2.3. okay, and now system.out.println fx plus c at, for example, 0. What happens here? And we get 2.3. If I put 1 here, I should get 3.3. If I put 10 here, I should get 12.3. If I put minus 10, I should get minus 10 plus 2.3, 7.7, minus 7.7. Yes. So the overloading works great, and you can make more complicated things. So let's have another function, f complex, or f complicated is fx times fc1 plus 2.3 or something plus 5. Okay, so instead of doing actually let's try this first. So instead of creating a constant function and then adding it to fx, I could just directly add 2.3. okay, so it is allowed to add a number directly to a function object, and the return type is also function. Okay, and then f complicated dot get value at 0 or at 1, for example, it should return 3.3. okay. Alright, this was the first step. In the next videos, we are going to add more functions and develop it in a full-fledged symbolic package in Java. Thank you for watching.